Okay, hello guys. So today we are talking about the next part of the substitution method. Okay, so for this kind of method, you can just try to think like here is integration from 1 to 4, and here is 2 minus x times e power of negative 2x dx, right? Okay, so if you want to solve for such problems, I believe you can just using this method like integration u dv equals to uv minus integration v du. Okay, so just remember that this is a very important formula. So here you can just consider here is 2 minus x and e power of negative 2x dx. So maybe here is just not udv and vdu, but you can just put e power of negative 2x as the last position of the x, okay? So you can say here, integration from 1 to 4, 2 minus x, and here is d e power of negative 2x, okay? So we can just set like, we want to differentiate e power of negative 2x, and it is negative 2 times e power of negative 2x, right? So here we can set here equals to negative a half integration from 1 to 4, 2 minus x d e power of negative 2x, okay? So for this kind of equation, now you can write using the integration u dv equals to uv minus integration v du, right? So we can just written as negative a half. Here is for 2 minus x times e power of negative 2x from 1 to 4 minus here is for integration 1 to 4 e power of 2 negative 2x d 2 minus x, right? Okay, so we can just consider like d if we put the value after d, that is integration, right? And if we put the value before d, that is differentiation, right? So for the first part, we can set like here's the value is negative a half, and when x equals to 4 is negative 2 e power of negative 8x, right? Sorry, negative 8, right? And when x equals to 1, the value is minus, here is for e power of negative 2, right? That is for the first value here. And if you want to solve this, that is minus integration from 1 to 4, and 2 minus x in differentiation, that is negative 1, right? So here is for plus e power of negative 2x dx, right? Okay, so for this value, you can read that as negative a half, negative 2 times e power of negative 8 minus e power of negative 2. And for the second value, you can just try to calculate. Here's for negative a half e power of negative 2x, and from 1 to 4. Okay, so because negative a half power e power of negative 2x, that you can differentiate it. You can find the value here is for e power of negative 2x, and negative a half is gone, right? So then you can put in 4 and 1 into it. So that the value here is for negative a half 2 e power negative 8. Here's minus e power negative 2. And here is for minus, here a half e power negative 8, and plus a half e power negative 2. Okay, so we can just add here that is for 4, and here's 5. 5 over 4 e power negative 8. And here is for plus 1 over 4 e power negative 2. Okay, that is for this problem. Okay, so let's move into some other quick practice for you. Okay, so let's back to our first question here. So this is using the like the substitution method, right? So for 3x squared, we can just set if you make an integration after it. So 3x squared, if you make integration, that is for x cubed plus c, right? So you can just consider it's 4 because c can be chosen as any constant number, right? So this integration can be written as integration for 1 over x cubed plus 4 dx cubed, okay? Dx cubed plus 4, okay? So then you can say, just let u substitute as x cubed plus 4. So it is integration 1 over u and du, right? So for this value, you can just set like 1 over u du integration. That is for ln u plus c, right? So here, the u is for x cubed plus 4. So that value is ln x cubed plus 4 plus c, okay? That is for the first question here. And for the second question, you can just consider like maybe you can first trying to simplify a little bit. So for okay, so for the cosine 2x, one minus it, you can just set is integration 2 sine x and 1 minus for cosine x squared minus the sine x squared, right? Okay, dx. So the value can be written as 1 over sine x dx, right? 1 over sine x dx. So for this kind of problems, you can just try to just consider, for this problem, you can just written that as, sorry, here is for 1 minus, sorry for that. Maybe here is for integration to sine x, and we can all turn into the cosine x, right? That is for, I guess it's for 2 cosine x squared minus 1, right? So it's 2 minus 2 cosine x squared dx, okay? So we can just add like sine x integration. So it's for negative cosine x, right? So we can just add that the value here is for integration for d cosine x, and here is for negative cosine. So here we've added negative here. So it's 1 over 1 minus cosine x squared x. Okay. So for this value, you can just consider here is for a negative integration for 1 over 1 plus cosine x plus 1 over 1 minus cosine x, okay? I believe we had to add a half here, right? Yeah, we had to add a half here, and d cosine x. So because we knew that d cosine x differentiation is for negative sine x, and cosine x plus 1, also the differentiation is for negative sine x plus 1, right? Negative sine x, there's no constant anymore, right? So you can just say for the first value, you can consider is negative a half integration for 1 over 1 plus cosine x d1 plus cosine x, okay? Plus integration one over 1 minus cosine x d. Maybe here is for negative, right? Here is for plus, okay, plus a half 1 minus cosine x, okay? That is it. So you can just calculate the value here. That is for half ln 1 minus cosine x over 1 plus cosine x plus c, okay? That is for the second question here. And for the last question, we can just add like sine x cosine x power 4 dx. So you can just let the u equals to sine cosine x, okay? U equals to cosine x. So you can just put sine x after that. So the value here is for negative 0.0 to 2 pi over 2 cosine x power 4 d cosine x here, okay? So that we can set, just let cosine x equals to u, that is for like elective, maybe here's 1, and maybe when x equals 0, cosine x equals to 1, and then when x equals to pi over 2, the cosine x equals to 0, right? So we can also just set like here's for u power 4 du, right? So it's for negative 1 over 5 times u power 5. Here's from 0 to pi over 2, right? So you can put pi over 2 and 0 into it. So that is for negative 1 over 5. Like here is for pi over 2 power 5. Sorry. Here is for 1, 2, 0. Oh, sorry, here is for 0 power 5 and minus 1 power 5, right? So the value here is for 1 over 5. Okay, that is for the question 3 here, okay? Well, that's for all the place our lesson. I hope you can truly understanding for how to calculate the integration here, okay? So see you next time. Bye.